Hello everyone, welcome to Sangam tutorials, Speak Gubbi online classes. So this is session 48, very important session on light we are going to come across. So in the last class we had discussed regarding the formula derivations. So that is sign convections for concave mirrors and sign convection for convex mirrors, and then we went with the mirror formula, relation between F, U and V. So let us recall it mathematically here. So 1 by F is equal to 1 by U plus 1 by V, which is called as the mirror formula. That is linear magnification, that is M. M is equal to H dash by H. So linear magnification of a mirror is the relationship between the height or size of the image to the height or size of the object. So that is M is equal to H dash by H. So this is the formula here. So M can be positive as well as negative. So M is positive when the height of the object and as well as the height of the image are both positive. That is, the object and also the image, if they are on the principal axis, then the magnification will be positive. So that happens usually in case of virtual and erect images. So magnification can be negative if the object is placed above the principal axis. So usually object is always above the principal axis, and if the image formed of the object is below the principal axis, then we say that magnification is negative. So positive magnification and negative magnification, and the relationship between M is equal to minus V by V, that is minus V by U. So this was the formula derived, that is sign convections for concave mirrors. So when we relate these two, so H dash by H will be equal to minus V by U. So this is the most important result we had got. So based on all these four formulas, we are going to solve some numericals on mirrors. Very important. You have to understand a lot of things here. You should know how to apply. I know you are very good in the theoretical background. So let us go with the problem here. So the first problem goes like this: a concave mirror. So when you read the mirror, what type of mirror is that? So the mirror should come into your mind. Okay, concave mirror, outer surface is silvered and inner surface is reflecting. A concave mirror produces 2 times magnified real image. So in the sense, object is smaller but its image is very big. So object is small, image is very big. This happens in case of a real image, that is in case of concave mirrors, right? Magnified real image of an object placed at 10 centimeters in front of it. So let us, for our reference, draw a ray diagram for this. So it is not required in your examinations. These ray diagrams are not required in your examination, but for our reference, I am going to draw it. So this is the principal axis, very simple, center of curvature, and this is the focus. Now, this is a concave mirror, produces 2 times magnified real image of an object placed at 10 centimeters in front of it. Okay, let us place the object somewhere here. That is 10 centimeters here. Let this distance be 10 centimeters. See, because in a concave mirror, if you place the image between C and F, then the image formed by this object will be, that is the image formed by the mirror will be bigger than the object. So at C, if you place the object, the image will be equal to the size of the object. So if you want the image of the object to be bigger than the size of the object, therefore the object has to be placed in between C and F, so that the image maybe you are going to get beyond C. So this is where the image is formed, that is A dash, B dash, this is AB. This is how it has something happened. A concave mirror produces 2 times magnified image. For example, this is X centimeters, this will be 2X centimeters. If it is 5 centimeters, this will be 10 centimeters, something like that. So it is magnified. So 2 times magnified real image of an object placed at 10 centimeters in front of it. So real images are always inverted, so therefore I have drawn the image below the principal axis. So now what we have to find out is find the position of the image. So find the position of the image means the image will be behind the principal axis. So we have to find at what distance the image is formed from the pole of the mirror. That is, you have to calculate the value of V. We have to find out. So U is given, so we have to find out V, and the magnification is given. So magnification is 2 times the image, that is size of the object. 2 times the size of the object means here the image formed is a real image. Therefore, the magnification for real images is always, please remember, it is negative. So magnification is negative in this case. So these are the things you have to think and speak to yourself, talk to yourself before entering into the problem. So this is the numerical. Let us get into this. So here, object distance. So object distance is indicated by U, right? So U is equal to, that is 10 centimeters. So U is equal to 10 centimeters means you are measuring this 10 centimeters against the direction of the incident light rays. So therefore this should be taken as minus 10. So U is equal to minus 10 by sine convection. You have to write this. By sine convection, you have to write this, right? Because as I told you in the previous session, one important note, what all the values you are having with you, you can apply the required sign according to sine convection. But do not apply any sign for the value for which you are going to find out. Automatically, that value will get its required sign at the end of the answer, right? Keep this in your mind. So object distance is U, that is minus 10 centimeters by sine convection. So magnification is M is equal to, that is minus 2 times, that is 2 times. Mirror, concave mirror produces 2 times magnified image. So therefore 2 should be written, but along with that you have to apply minus sign to that, because this is a real image and magnification is negative. So object is above the principal axis, image is below the principal axis. So this is positive and this is negative. Therefore magnification becomes negative. So M is equal to minus 2 by sine convection. So reaching to the answer is not a big thing. How to reach to the answer is not a big thing. The way how you reach the answer plays a very important role. So you have to think, you have to apply your knowledge and then solve numericals on physics, right? So M is minus 2, so we have to find out the value of V, that is image distance. Image distance is equal to V is equal to how much? Don't put any sign for this because you are still finding out the value of V. So now for our reference we will speak. When I get the value of V here, will that V value be positive or negative? It will be negative because you are measuring from the pole of the mirror towards the object, that is towards the image. So this is the position of the image. Position of the image means at what distance the image is formed from the pole of the mirror, and this measurement is done against the, that is incident light rays. Therefore this distance will be sure negative, but don't apply that negative sign in the data. That's very important. Okay. So now we have 3 things here. So one is U, one is V, and another is M. So we have the relation M is equal to minus V by U. Apply the formula. Applying the formula, right? So M is minus 2. Minus 2 is equal to minus V by U is minus 10. U is minus 10. So we'll go with cross multiplication. Minus V into 1 is minus V is equal to minus 2 into minus 10. So minus V is equal to minus 2 into minus 10 is that is plus 20. So V has negative sign. Transfer this negative sign to the RHS, that is multiply both sides by negative sign. So minus V into minus is equal to 20 into minus. So minus into minus is plus V, that is plus V is equal to minus into 20 is equal to minus 20 centimeters. See, this is the beauty of problems in physics. So here automatically the V value has got minus 20 centimeters as the answer. So here while writing the answer, don't consider the negative sign. but while putting the answer inside the box, maintain the sign. So therefore, the image is, we'll write the answer here, the image is at a distance of, the image is formed at a distance of 20 centimeters. So write just 20 is enough. But while giving the answer, show that it is minus 20. So the image is formed at a distance of 20 centimeters from the pole of mirror or from the mirror. Okay. Mirror in front of it. It's understood. In front of it. So this is how we have to present the problem. Right. Okay. Okay, we'll go with the next problem, very important, which was asked in 2006 and 2011 Cbse final examinations, and also this problem is found in the exemplar of physics. Right. So, an object 5 cm in size, height, both are one and the same. An object 5 cm in size is placed at a distance of 20 cm from a concave mirror of focal length 15 cm. So if you cannot visualize, no problem, draw a rough ray diagram so that you can easily analyze. Okay, so this is the concave mirror. So this is the pole of the mirror. This is the pole. This is the center of curvature. This is the principal focus. Now, an object 5 cm size is placed at a distance of 20 cm from a concave mirror of focal length 15. Okay, so this is the focal length. This is 15 centimeters, and this will be again 15 centimeters. So 15 plus 15 is 30 centimeters here. But the object is placed at a distance of 20 centimeters from the concave mirror. So it will be, the object will be placed beyond F but inside C. So it is in between C and F. The object is placed somewhere here. Right. So this is AB. This is AB. So 20 centimeters in the sense from here to here we have 5 centimeters. So mirror of focal length 15. So F is F value. This is the F value, that is 15 centimeters. So object of height 5 centimeters. So height is 5 centimeters. It is given. Placed at a distance of 20 centimeters from a concave mirror. So here this becomes the object distance. Object is here. So that is 20 centimeters. So this is nothing but the value of U. U value we have got. Okay. At what distance from the mirror should a screen be placed? Now we have to keep a screen where the image is formed. So here, when the object is placed between C and F, the image will be formed beyond C. So somewhere here the object, the image will be formed. So here, where you have to keep the screen? Where you have to keep the screen is the same as where is the image formed in front of the mirror. Both are one and the same. So where the image should be, where the screen should be placed is, you have to place the screen here so that you get the exact image, that is exact sharp image of the object on the screen. So at what distance from the mirror? So at what distance from the mirror should a screen be placed to get a sharp image? So it's nothing but at what point in front of the mirror the image is formed. That's the question here. So where the image is formed, at that point you are going to keep the screen to get the sharp image. So find the size of the image. You have to find the size of the image. That is, you have to find the value of h dash. So size of the image means it is the height of the image. Both are one and the same. So now let us go with the data. Framing data using sign conventions is very important. If you do some wrong things here, if you do some simple mistakes here, entire problem will be wrong. So be careful. So let us go with this. Right. First write the focal length. So focal length is equal to F is equal to, it is 15 centimeters given in the problem. So we have to think whether it is plus 15 or minus 15 according to sign conventions. Now, in case of a concave mirror, in the previous classes I have told you, focal length is always negative because you are measuring this distance against the direction of the incident light ray. So therefore 15 becomes minus 15 by sine convections. By sine convection. Okay. So next we take the object distance. So object distance is equal to, that's represented by u, is equal to 20 centimeters. So after writing the numerical, think whether it is positive or negative. So here object distance is measured from the pole of the mirror to the object, which is against the direction of the incident light rays. Therefore it will be minus 20 centimeters by sine convection. Same thing. Next is the height of the object. So height of object, that is represented by h, is equal to 5 centimeters. Write the numerical value, then decide whether it is positive or negative. So this is 5 centimeters and this is above the principal axis. Therefore this 5 centimeter remains positive. That is 5 centimeters. So you have to find the image distance, that is this one. So image distance is equal to, V is equal to how much? Don't put any sign for this, because still you are going to find the value of V. Therefore don't put any sign for the unknown, what you are going to still find out. Okay. So look at the things. You have F, you have U, you have H, you have V. So that is, you have to find the V. So you have F and U, and you can find out V by using the mirror formula. Very important. So by mirror formula, so 1 by F is equal to 1 by U plus 1 by V. So 1 by F is 1 by, F is minus 15, write minus 15 is equal to 1 by U. U is minus 20, so write minus 20 plus 1 by V. Don't put any sign for V until everything gets simplified by itself. Alright. So it is 1 by minus 15 is minus 1 by 15, and this is equals. So we will transpose this. That is 1 by minus 20 is minus 1 by 20. So that becomes minus 1 by 20. When it goes to the LHS, that becomes plus 1 by 20. So is equal to 1 by V. Right. So here for 15 and 20. Right. So we will go with the LCM for 15 and 20. So here, okay, you can also go with the cross multiplication. It will be, so 15 and 20 LCM is that is 15 and 20. You can take out the LCM. So 5 3s are 5 4s are, so 3 ones and 4 remains 4 ones. So 5 3s are 15. 15 4s are, that is 60. 60 is the LCM for this. Okay. Right. Minus 1 by 15 into 60. 15 ones are 15 4s are, 4 into minus 1 is minus 4 plus 1 by 20 into 60. That is 20. 1 by 20 into 60 is 20 ones are, 23s are, 3 ones are is 3 is equal to 1 by V. So minus 4 plus 3 is minus 1 by 60 is equal to 1 by V. So take reciprocal on both sides, because we have 1 by V but we want V. So therefore take reciprocal on both sides. So it becomes V is equal to that is 60 by minus 1. So minus 1, that is negative sign can be transposed, that is transferred to the numerator. So V is equal to minus 60 centimeters. So here according to our ray diagram it is perfectly matching. So V is equal to minus 60 means the image is formed at a distance of 60 centimeters from the pole of the mirror. So this is 60 centimeters. So here why we have got negative sign? So you can easily see that why we have got negative sign, because here whatever we measure from the pole of the mirror against the direction of incident light should be negative. Therefore we have got the negative sign for the size of the, that is distance of the image from the mirror. So what should a screen be placed to get a sharp image? So the screen should be placed, you have to write the statement. Screen should be placed at a distance of not minus 60 or right 60 centimeter from mirror. Okay, so we'll find the next question. Find the size of the image. Find the size of the image or find the height of the image. So this is the thing you have to find out. So we have a relation for that. So h dash by h is always equal to minus v by u. So this is the thing what we have already derived it. So h dash we have to find out by h. H is plus 5, that is this measurement, that is plus 5. 5 is equal to minus v by u. So v minus sign is for the sign, that is in the formula. So v is that is what we have got here. It is 60 centimeters. 60 by, so that is minus 60. We have got u that is minus 20. So h dash into 20 is minus 20. H dash is equal to 5 into that is minus into minus is plus 5 into 60, that is 60 into 5. So h dash is equal to 60 into 5 by minus 20. So minus 20 once, minus 20 minus 3. So h dash is equal to minus 3 into 5 is minus 15 centimeters. So here minus 15 centimeters indicates that the image is a real image. That is, the image is a real image because it is found below the principal axis. So therefore height of image is minus 15 centimeters, that is 15 centimeters. So this is for 3 marks in your examination. Very important, you have to practice this. Okay, we'll go with the next problem. Very important, very classic problem in light. Okay, an object 4 centimeter high. High is the height of the image or size of the image. An object 4 centimeter high is placed at a distance of 6 centimeters in front of a concave mirror. Okay, let us draw a concave mirror for our reference. So this is a concave mirror. This is the principal axis. So it's only for our reference, not to be drawn in the examination. Just you can draw a rough figure, put the values for confirmation. An object 4 centimeters. Okay, before that we will mark all these things. This is the pole. Okay. An object 4 centimeter high is placed at a distance of 6 centimeters in front of a concave mirror of focal length 12 centimeters. So focal length is 12 centimeter here. So this is the focal length. So we'll write the data here itself. So focal length is equal to f is equal to, it is 12 centimeters. So it is positive or negative, you have to think. So since concave mirror's focal length is always negative, so you have to put negative sign here. Okay. 6 centimeter high, distance 6 centimeter is front of a concave mirror of focal length 12 centimeters. Find position, nature and size of the image. Right, very important. Look at here. An object 4 centimeter high is placed at a distance of 6 centimeter in front of concave mirror. So focal length is 12 centimeters. Object is placed 6 centimeters from the pole of the mirror, means it is placed between F and P. So this is 6 centimeters. So this length is 6 centimeters. So this is focal length and this is the object distance, that is U. So we'll write the object distance. Object distance is equal to U is equal to, that is 6 centimeters. So whether it is positive or negative, it is 100% negative because it's against the incident light rays. So it is minus 6 centimeters. So now an object 4 centimeter is in height, that is the height of the object is, that is height of object. Height of object is h is equal to, that is 4 centimeters. So this is 4 centimeters. So no problem because it is positive because it is placed above the principal axis. You are measuring something above the principal axis. So if focal length is 12 centimeters, find the position, nature and size of the image. You have to find the position of the image which is formed. So we know earlier that in the ray diagrams, that is the sixth ray diagram for concave mirrors, when the object is placed between F and P, the image is formed that is beyond the mirror, that is virtual image is formed. So, right, so therefore our answer, what we get here, the position, it will be positive, because it's beyond the mirror, it's virtual and erect. And also you have to find the size of the image, that is h dash, you have to find out. So we will go with the things. So first we will find, first we will write the data. So let height of image is equal to h dash is equal to how much? Okay. So here we have two things, f, u. We have to find the value of v. Let us find out v here. So this is nothing but the image distance, that is v. So v here. So by mirror formula we will use, by mirror formula 1 by f is equal to 1 by u plus 1 by v is the mirror formula. So 1 by 12, that is minus 12, is equal to 1 by minus 6 plus 1 by v. So we will transpose the things. So minus 1 by 12 minus, that is minus goes here, minus 1 by 6, minus 1 by 6 goes to that side, that becomes plus 1 by 6 is equal to 1 by v. So here again, so 1 by v is equal to, that is for 12 and 6 we have to take the LCM, that is 2 6 are 12, 2 3s are, that is again 2 3s are and 3 3 1 1, 2 2s are 4 4 3s are 12. Okay, so 12 becomes the LCM. So minus 1 by 12 into 12 is minus 1, plus 1 by 6 into 12 is 6 1s are 6 2s are 12 into 1 is 2. So 1 by v is equal to minus 1 plus 2 by 12 is, that is 1 by 12. So we have 1 by v is equal to 1 by 12. So taking reciprocals, 1 by v is equal to 1 by 12. So therefore v is equal to 12 centimeters. So what is this? So here it is the image distance. The distance of the image from the mirror is, that is 12 centimeters. So you can see the 12 what we have got as is positive, because this v is being measured from the pole of the mirror to the object along the direction of the incident light rays. So therefore the value what we have got is, that is positive. So since v is positive, therefore image is virtual and erect, formed beyond the mirror or behind the mirror, it is formed beyond the mirror. Okay, now we will find out the h dash relationship is very simple. H dash by h is equal to minus v by u. So this is the formula for finding out the height of the image. So h dash is we have to find out. So that is h dash by h is, that is 4 centimeters is equal to minus v. Write the minus sign, put the v value. V value is 12 by, that is u. U is minus 6 centimeters. So that is minus 6. So h dash is equal to minus cancels. 2 3s are 2 6 it goes. 3 1s are 3 2s it goes. So by 4 is equal to 2 by 1. So h dash is equal to 4 into 2, that is 8 centimeters. So height of the object, that is image formed behind the mirror is, that is 8 centimeters. It is virtual and erect. So this is again for 3 marks. Very important. Let us get into the next problem, which is very important, which was asked in 2011 final examinations of Cbse. A 2 centimeter high object is placed at a distance of 20 centimeters from a concave mirror. Okay, for reference, I will draw a concave mirror. Right. So this is the principal axis, pole of the mirror, center of curvature, principal focus. A 2 centimeter height, that is the size of the object, is placed at a distance of 20 centimeter from a concave mirror. I don't know what is the focal length here. I don't know what is the focal length. So therefore, I cannot tell you where to place the object here. So maybe I will take somewhere here. It's I don't know actually, because I do not know the focal length for reference. So at 2 centimeter high, so object is 2 centimeter high. Object is placed at a distance of 20 centimeters from a concave mirror. So this is 20. This is 20 centimeters. Okay. Concave mirror. A real image is formed at 40 centimeter from the mirror. So the real image is formed at 40 centimeter means somewhere here the real image is formed. So this distance is 40 centimeters. So my diagram is quite okay to the data. So this is U value and this is V value. So now using this, find focal length of the mirror. So that is you have to find the value of this. That is, this is the focal length. So you have to find this value. So V is given, U is given. You have to find out F. Very simple. By using mirror formula, you can easily reach it. But we will write the sign conventions first. So object distance is equal to, object distance is nothing but indicated by U. U is equal to, is given as 20 centimeters. 20 centimeters, write the value, then decide the required sign. So as it is a concave mirror, object is placed in front of it. So therefore U becomes minus 20. So image distance is equal to V is equal to, that is 40 centimeters against the direction of light rays. So it is again minus 40 centimeters. So I will find the focal length. So focal length is equal to L, that is F is equal to question mark. So to my consideration, as this is a concave mirror, the focal length should be negative. The value should be 100% negative. So let's see. So by mirror formula, right. So 1 by F is equal to 1 by U plus 1 by V. So 1 by F is equal to, okay, 1 by U. 1 by U means it is minus 20 plus V means it is minus 40. So keep it inside brackets. So next is 1 by F is equal to minus 1 by 20, that is plus into minus, it is minus 1 by 40. So 1 by F is equal to 20 and 40, LCM is 40, 1 by minus 1 by 20 into 40 is 20, 1s are 22s are, that is minus 2, minus 1 by 40 into 40 is 1. So 1 by F is equal to minus 3 by 40. So let us take the reciprocals on both sides. So F is equal to 40 by minus 3. So let us divide 40 by 3. So 40, let us divide it. 3 1s are 3, 10 is 10. That is, let's do one thing. 3 13s are, that is 13 3s are 39, 1 remains. 0.033s are 9, 1 remains. Again 0, 3 3s are, so it's recurring. So F is equal to minus 40 by 3 is minus 3 1s are minus 3 minus 13.33 times. So it is minus 13.33 centimeters. So you can see here the value what we have got is negative. Why we got the negative sign? Because the focal length of a concave mirror is always negative. Right. So by this I would like to conclude. I hope you have enjoyed the entire session today of numericals on light concave mirrors. So still more problems are going to come. Still 3-4 days we will be still going with the same problems on concave mirrors and concave mirrors, which are very important. I hope you enjoyed the entire session. So it's an humble request that last date for the payment of fees is June 10th. It's a gentle reminder for you. I hope you will fulfill your responsibilities so that I can give you more and more knowledge to you and make you a highly successful students in the examinations. And I want just you students to come out with colorful results on the day of results. So you should get knowledge as well as marks. That's my aim, right? To fulfill that aim, you have to support me from your heart by paying the fees so that I can run this show for a long time, right? So stay home, stay safe and keep learning. Thank you.